Hello everybody, and thank you for joining our talk with the title Interpupillary to Intercamera Distance of Video See-Through AR and its Impact on Depth Perception. We are Chandni Murmu and Franziska Westermeier. This paper is a cooperation between the Clemson University and the HCI and Peace groups of the University of Würzburg. In Video See-Through AR, cameras on the front face of the HMD capture the environment and the image is rendered in real time into the HMD. VST AR HMDs have adjustable lens to match the user's interpupillary distance. However, the intercamera distance of these HMDs, responsible for the video pass-through, relies on fixed camera positions, creating a discrepancy between the stereo parallax of the pass-through camera image and the rendered virtual content. The IPD is normally distributed across population with a mean value of 63.3 mm. Taking the MetaQuest 3 as an example, which is a video see-through AR and a VR mode, we can adjust the inner lenses to this range. Hence, the virtual content in the VR mode without the pass-through can be adjusted within this range. In VST AR, the ICD is fixed to a value of 63.5 mm, which means that only a small amount of population sees the video and the rendered images with the matching stereo parallax. The remaining might face spatial distortions from conflicting depth cues. So for us, the question arises, how does this impact depth perception? And if it has a negative impact, can we adapt to the error by perceptual motor calibration? Past studies in virtual reality have shown a systematic underestimation of distances, called the depth compression effect. For VST AR, studies have found more misjudgment when compared to optical see-through AR and VR. These results have been attributed to perceptual incongruencies in VST AR. One of them, we hypothesize, is the IPD-ICD difference. Some studies focus on the IPD mismatch, which, for example, occurs for HMDs, where the inner lenses cannot be adjusted and do not match the user IPD. Results in VR, in medium field distance, showed no effect. Taking this to AR and considering the ICD as well, we found no research that has empirically evaluated the IPD-ICD mismatch. However, there are conceptual papers that hypothesize a potential impact. Depth misestimation can be reduced using action and feedback-based task calibration. Real-world calibration has shown improved accuracy of distance estimations, and these findings were also already proven in VR, and there's recent evidence for this effect in video see-through AR. So we pose the following hypothesis. We hypothesize that the depth misjudgment will be higher in VST AR when compared to VR, and also will be higher as the deviation between IPD and ICD increases. For perceptual motor calibration, we hypothesize that depth misjudgment in VR as well as in VST AR will be lower after a calibration phase. For spatial presence, our hypothesis was that it will be higher in VR than in VST AR. Our experiment design followed a 2x3 mixed factorial design, with VR and VST AR as between subject factors and pre-calibration and post phases as within subject conditions. The different phases looked like the following. In the pre and the post phases, which are basically the same, a target appeared. Participants then extended the arm and vision goes black. They blindly position the tip of the controller at the estimated target position and confirm. Then they retrieve the arm to the resting position. In the calibration phase, after confirming the estimated target position, the controller is kept at that position and vision is immediately restored. This allowed the participants to observe the difference between the actual and the estimated position, make adjustments, and confirm again. We measured the perceived distance and the time per trial for our objective measures. For subjective measures, we assessed presence, task load, and some control measures, such as VR sickness and a debriefing interview. We calculated 3 different linear mixed models for the objective measures. This type of test has different advantages. For example, it allows continuous variables, such as the IPD. These models were, first, the perceived versus actual distance. Then we had the signed residual error, showing the error in standardized units, as we had here millimeters, and the signed proportional error, which reflects the relation to the distance to target. 72 participants took part in the experiment, which resulted in around 6,500 data points in total.
From perceived versus actual model, we found that the actual distance increased perceived distance by 0.95 millimeters for every 1 millimeter increase in the actual position, suggesting a consistent underestimation. And switching from VR to AR increased underestimation by 13.9 millimeters, approximately 14 millimeters. The other two models showed similar effects. For hypothesis 1.2, we found evidence from perceived versus actual and signed proportional error models. From perceived versus actual model, we found that the IPD-ICD difference decreased perceived distance by 2.57 millimeters for every 1 millimeter increase in the signed IPD-ICD difference. In the graph, you can see the increasing underestimation in VST AR with smaller IPD. A similar result was found from the signed proportional error model. We cannot accept both hypothesis 2.1 and 2.2. While the calibration phase showed improvement, there was no carryover to the post phase. However, in the debriefing interview, 31 participants reported a perceived positive change in their performance. We cannot accept hypothesis 3.1 as we found no notable difference between VR and VST AR in the spatial presence ratings. To come back to our previously posed question, our study confirmed that depth perception is indeed influenced by the XR mode and the IPD-ICD difference. As we did not find evidence of calibration influencing near-field depth perception, further investigation is needed. Given these results, we encourage future studies to more closely monitor the participants' IPD, as it potentially affects depth perception and performance. These are a few references for our study, and we thank you for your attention.